Welcome to the DIY Retro channel. I know that the title of today's video is a bit exaggerated, a little bit clickbaiting, but after watching this video you would understand better why radio receiver Detefon can be called Polish Starlink of 30's. But to understand it better, we have to travel back in time to the Second Polish Republic at the turn of the 20s and 30s of the 20th century. So let's go back in time for a moment. This is what the map of Europe looked like until the end of World War I. As you can see, Poland is not on it. However, by taking advantage of the geopolitical opportunity at the end of the war, the Second Polish Republic was established. Thus, Poland returned to the map of Europe after 123 years of partition. The young Polish state was extremely undeveloped and poor. The authorities at the time, led by Józef Piłsudski, faced the challenge of industrializing the country, including making radio more accessible to the citizens. In 1926, Polish radio began broadcasting. In its early years, radio broadcasting in Poland developed very slowly due to the lack of a nationwide radio distribution initiative, the country's low electrification level, low incomes of the population, and the high cost of radio receivers. Polish villages in the 1930s were extremely poor and had no access to the electricity at all. That's why in 1929 Polish Radio commissioned the state communication factory to design and start the production of an affordable radio receiver named Detefon. The designer of the Detefon was engineer Wilhelm Rodkiewicz, a graduate of the Faculty of Electrical Engineering at the Warsaw University of Technology, so a graduate of the same faculty at the same university as me. The crystal radio was based on a simple circuit that receives radio waves via an antenna and it converted them into sound using a detector, which was a galena crystal. The receiver had no external power source. It obtained the energy needed for operation directly from the radio waves. The advantage of the Detefon was its low price and the fact that it did not require an electrical power supply or batteries. In a way, it could be called an ecological receiver. In articles about it, the emphasis was placed on the fact that the Detefon did not require an external power source, making it an ideal device of residents of non-electrified villages. It also worth noting that the distribution of the receiver by the Polish Post further facilitated the spread of the device in rural areas far from stores, which was an unconventional way to distribute electronic devices. And I think all these things, it was fascinated me the most about the entire national radio broadcasting project. Imagine a simple farmer in a highly undeveloped country where only about 2% of land was electrified suddenly had the opportunity to listen to radio broadcasts, music, news and more. From my point of view, this was a real game changer, something comparable to what Starlink is for areas of the world where internet access is difficult. What you see is schema of circuit of original Detefon. My receiver is a little less complicated. It consists of three main components: an air coil, a variable capacitor and a germanium diode. The use of germanium diode is crucial because the voltage drop across the semiconductor junction is approximately 0.3 volts, which is key for proper reception of radio signal, especially we are talking about a receiver that does not use any external power source other than the energy from electromagnetic waves. Of course, to listen to broadcasts you also need to connect a speaker, and note it cannot be any speaker. It must be a high resistance speaker, ideally with resistance over 2 kilo ohms. The popular buzzer, also known as a piezoelectric speaker, will work perfectly as a loudspeaker in this case. In order to receive the 225 kHz frequency, because this is the frequency on which the first program of Polish radio is broadcast, amplitude modulated, I have to select the appropriate values of L and C elements. For this purpose, I use the formula F equals 1 divided by 2 times pi times square root of LC. The coil wound has an inductance of 11.5 mH, so rearranging the formula, my capacitor should have a capacitance of about 43.5 picofarads. Okay, but it's also worth emphasizing that the most important aspect is having an antenna as long as possible. The longer the better. Truly, the antenna is a crucial component in this project. Since the receiver is designed to pick up long-wave radio signals, the antenna should be as long as possible and positioned high above the ground. Okay, let's talk about the principle of operation, that kind of radio receiver. The radio wave is an electromagnetic wave. To simplify our understanding, I've drawn an electromagnetic wave of constant amplitude and constant frequency as a harmonic wave with a sinusoidal waveform, yeah, right behind me. Well, okay, but signal with constant amplitude and constant frequency does not carry any information for us, radio listeners, right? We care about hearing the radio broadcast signal, which is basically acoustic signal. The radio wave, in our case 225 kHz of frequency used by the first channel of Polish radio, which employs amplitude modulation. Amplitude modulation is the key in the entire project, yeah? Our radio wave with 225 kHz of frequency is the carrier wave for the audio signal of the radio broadcast. This is our carrier wave, yeah. Amplitude modulation involves overlaying the audio signal of the broadcast onto the carrier wave, which causes changes in amplitude of the carrier wave in accordance of the frequencies present in a transmitted broadcast. Yeah, this results in an amplitude modulated signal. So our carrier wave after amplitude modulation will look something like this, and give me a second, right? Something like... Okay, I hope you can see something on this drawing. As you can see, the superposition of acoustic signal with different frequencies, our acoustic signal has different frequencies, has affected the changes in amplitude of our carrier wave. Our carrier wave still has a constant frequency of 225 kHz in our case. Yeah, as you can see, overlaying the acoustic signal on our carrier wave causes changes in amplitude of our carrier wave, and this is what amplitude modulation is. Alright, but how can we listen to such a transmitted radio signal? After all, our antenna receives various of radio frequencies, and we want to listen to just one specific radio frequency, in our case 225 kHz. For this purpose we use LC resonant circuit, and by appropriately selecting the values of coil inductance and capacitor capacitance, we set a resonant frequency of a circuit, so all other frequencies picked up by antenna are grounded, while our frequency, in our case 225 kHz, encounters very high impedance of the circuit, cannot be passed through the circuit toward the ground. In other words, it resonates with our circuit and goes towards to the diode, and a diode acts as a detector in our case, passing only upper part of the radio signal, okay? Only the upper part of the radio signal. This is the crucial component. The diode is a crucial component in our radio receiver. Okay, our waveform after passing the diode looks something like this, and give me a second. Okay. Okay, I hope you see this clearly that we have here only the upper part of our waveform, because the diode, okay? The diode allows pass through only the upper part of our waveform, our radio signal that we've picked by the antenna. Why this is very important? Because take a look at this waveform. At any time of this waveform, average value of amplitude equals 0. So in that case we wouldn't be able to hear anything at all. That's why it's very important to have this diode. Diode, like I said before, allows pass through only the upper part, so the average value of these amplitudes does not equal 0. Yeah, so in this case we are able to hear our broadcast. I'm starting work on a receiver by making a casing. I use a pine box as a casing. By the way, the exact same I use to make my power bank power box. The link to the video where I built the power box should be displayed now. I'm start by drilling holes in which I place the headphone connections, antenna connector, grounding and a knob for turning the capacitor capacitance in order to properly receive the radio station. Of course, just like the original, I also painted my Detefon black. After the paint dries, I can safely start mounting the connectors in a housing. At this stage I'm also installing a variable capacitor, which I will use to tune to the desired frequency. To make sure that the capacitor is securely attached to the housing, I use small nails and a hot glue for assembly. As I mentioned when discussing the schematic of our receiver, in order for the receiver to work properly, in addition to the capacitor, we also need a coil. And honestly, I don't know how many turns I want, but after measuring the inductance, I'm sure it is about 11.5 mH. From the capacitor measurements, I'm certain that it has a capacitance in the range of 25 to 175 picofarads. Okay, the next step is to firmly place the circuit components in the housing, using the hot glue of course. In order for my receiver to resemble the original as much as possible, in which the galena crystal was placed in a glass outer tube, I also placed the germanium diode in a glass transparent outer tube. Since I don't have any fancy tools for cutting glass, especially glass in the shape of a laboratory test tube, I decided to use thermal shock to get the right length for my germanium diode housing. It so happened that the evening I was assembling my radio receiver, it snowed, so it works perfectly for cooling the test tube. This way I get desired length for my glass tube without risking breaking the entire laboratory test tube. In order to attach the tube to the radio housing, I made wooden stands, between which I will place the tube with the diode inside. Okay, the diode is placed in a glass tube, the tube is attached to the housing, so we can now solder all the components together according to the diagram. Okay, we have all the elements from the diagram soldered, so there's nothing left to do but close the casing, attach the knob for tuning the frequency, and our Detefon replica is finished. Encouraged by the final effect of working on my Detefon, I decided to make headphones especially dedicated to it. I I made the headphones from two buzzers, in other words piezoelectric speakers, pine wood from which I made the housing for the buzzers, and a steel wire to connect the both speakers. As you can see, I attached the piezo speaker in a wooden casing using small nails. Of course, you have to remember that they should not stick out on the other side. If so, you have to shorten them, otherwise listening to the radio will become really unpleasanting. Before connecting the speakers with steel wires so they fit comfortably on the head, I paint them black. Of course, both piezo speakers should be connected together. It's best to solder them together in series, because by connecting them in parallel, we reduce the equivalent impedance, which unfortunately will contribute to reducing the volume, so we connect our speakers in series. To make the headphones as comfortable as possible, I wrapped the middle part of the steel wires connecting the two speakers with double-sided tape. Then I wrapped a leather strap around it. Okay, the radio receiver and the headphones are finished, so it's finally time to see if the receiver built in this way can work. As an antenna, I use a long wire that I stretch from the chimney on a house to the test site, which is at least 40 meters long. As a grounding, I use a short copper pipe that I drove into the ground. Then I connected the antenna cable and the ground wire to my receiver. Okay, all connections have been made, so now only the best part remains, that is finding out how and whether such a receiver can work in today's conditions. Okay, we have groundings, antenna connection, the speaker, and let's find out if our replica of Detefon really works. Yeah, I can hear radio station. This is something like interview. Oh yeah, I can hear some song. You have to hear this. Hey, that's nice. Our replica of crystal radio really works. So, as you can hear, the volume level is quite low, but hey, this radio receiver is powered by anything other than radio waves. But still, I'm very happy of this project. So, thumbs up. Listen to radio broadcasts from my replica of Detefon is a real journey in time. The situation where you really have to strain your ears and focus on what you are listening to is something truly unique. As you can see, this afternoon I completely lost myself in listening to the radio. Incidentally, at night the reception of broadcast is much better, and this is due to the disappearance of the D layer in the ionosphere, thanks to which radio waves can reflect from the E layer, which is much higher. This translates into the range of radio waves and thus into the quality of the sound we heard. I think it turned out pretty well. Personally, I'm proud of the Detefon replica I made. I think it's my ambitious project so far, but of course I haven't said the last word yet. Now you probably know why the Detefon was so important for the Polish radio. I was most impressed by how the difficulties were dealt with. The receiver had to be cheap, easy to build, mass-produced, work without electricity, and also how they managed to distribute the receiver using the Polish post office, and the most importantly, how to radio the country where there's no access to the electricity. All these things made me so impressed by old engineers, technicians, and their unconventional thinking. So that's it in this video. If you like it, subscribe to the channel, leave a comment, give it a like, and see you soon in the next episode of DIY Retro Channel.